Hi, so today we're going to learn about graphing inequalities in systems of inequalities into variables. So in this section, I will graph inequalities in system of inequalities into variables by finding x and y-intercept. I will also shade the correct region. So this is, before we start, I'm going to go over definitions called the linear inequality definition. So if a and b and c are real numbers with a and b are not both 0, then ax plus by is less than c is called a linear inequality in two variables. So some examples are y is greater than x minus 3, 2x minus y is greater or equal to 1, x plus y is less than 0, and then y is less than or equal to 3. It's kind of like the linear equation, but the only difference is there could be a greater or less than or greater than equal sign. So that's really only the difference. So let's start with let's say we got to graph this right. 2x minus 30y is less than or equal to 6,000. So remember the way back when I was doing graphing linear equations, I would have to solve for y and find the y-intercept and find the slope. This case, I'm not going to do this. I'm going to do something a little different. I'm going to I will find the x-intercept, and then I will find the y-intercept, and then I will graph it, and then I will shade the correct region. So for this one, remember how to find the x-intercept. So let's find the x-intercept. You plug 0 into y, right? Plug plug 0 into y, so it's 2x minus 30, 0. And then I'm not going to put less than equal for right now. I'm going to put equal sign just for right now, because I got to solve for what x. So this is going to be 2x equals 6,000. Divide both sides by 2. So we get x equals 3,000. So our x-intercept is 300. Yeah, it's not 300, it's not 3,000, it's just 300. Okay, now let's find the y-intercept. To find the y-intercept, you plug 0 into x. So this is going to be 2, 0 minus 30y equals to 6,000. So that's going to be, this becomes 0, so it's just going to be negative 30y equals 6,000. Divide both sides by negative 30. So we get y-intercept is 0, negative 200. Right, because this becomes negative 200. Okay, so I could rewrite the original equation as 2x minus 30y equals 6,000. So what I do is I know the x-intercept and the y-intercept, so I can graph it. So let me graph this. Also, let's look at the original equation. So this has a less than equal sign, less than, this has a less than equal sign, right? So when it's less than equal, when there's an equal sign, that means it's solid. And then when it's just regular less than, it's just dash. So let me graph it. I'm going to set this, instead of 1, I'm going to just call it everything by 100s. So this is 100, this is 200, this is not in scale, this is 400. It's negative 100, negative 200, etc., etc. So this is the x and this is the y. So we said that our x-intercept is, here it is, 300 comma 0, so it's right here. And then our y-intercept is 0 comma negative 200, so it would be right here. Now we can connect the dots, but this time ours is less than equal, so it's going to be solid, not dash. Sorry for not making it straight. Okay, now the next step is we gotta shade the region. So how we shade the region is you pick a point that did not intersect it, did not touch it in any way. So I could use, I would always use 0, 0 or the origin because it's really simple. Because the 0, 0 could be our x and that could be our y. So you plug this into the original equation, not this equation, but the original, this one right here. So if you plug 0, 0 into that equation, you're going to get 2, 0 minus 30, 0 is less than equal to 6,000. So that's 0. So that's going to be 0 less than 6,000. Is this statement true? Is 0 less than equal to 6,000? Yes, right? It's less than equal to. If you ever do get confused, you could just draw in a numbered line. So here's 0 and here's 6,000. So 0 is less than 6,000. So that's true. So wherever the point was 0, 0 and it was true, so you would shade that only in that region. If it was false, you would shade it on the opposite side. If it was false, but since it's true, we shaded on the region on the where we got the point from. So here's 0, 0. I guess I could use another color if you want. So it's going to look something like this. Yeah, shade the whole side. Okay, so now you know how to do the shading. So let's do some more problems. Okay, so let's do this one. Y is greater than 2x, 2 to the x. We can also rewrite it as y equals 2x. So what I'm going to do is, let's look at this one, the original equation. So we know it's an exponential equation. So what do we know about exponential? It has a y-intercept of 0, 1, right? It's exponential. And since a is equal to 2, right, our base, we know it's increasing. So we can graph, since we know all those information, we can just graph it. Okay, so we said that the y-intercept is 0, 1, right? Let's see, what else do we know? Since it's greater than, there's no equal sign, it's going to be dashed. So we know it's going to look something like this. So okay, so we can call this y equals 2 to the x. Now we just gotta shade the correct region. So how I do that is I can use a point that does not cross it. So I could use this point 0, 0, right? So if I use the point 0, 0, I put this into the original equation, not this one, but this one. So that's going to be, that's our x and here's our y. So y is 0 greater than 2 to the 0 power, and then we know anything to the 0 power is just 1, so it's going to be 0 greater than 1. I think that is false, right? Because when you graph it on a number line, here's 0 and here's 1. 0 is not greater than 1. That's why it's false. So remember we got that point from here. If it was true, we would shade it in this region, but it's false. So we have to shade it in the opposite region. So I'm going to shade it a different color. So it would be this region, right? This whole entire region. Okay. Let's do two inequalities. So let's say you're given y is less than x minus 3, and then x is less than equal to 4. So I can rewrite y is less than equal x minus 3. I can rewrite that as y equals x minus 3, and then we can also the x is less than equal to 4. I can rewrite it as x equals 4, and the reason why I'm going to do this is because when I graph it, I have to label the graphs, and you can't have less than equal to, or you have to have like an equal sign. So let's start with this one. We know -3 is our y-intercept, right? You could start at -3 and then go up 1, right 1, up 1, right 1, or you could just find the y-intercept and x-intercept and graph those points. So we know the y-intercept is 0, -3. And then to find the x-intercept, you set 0 to y, so it's going to be 0 equals x minus 3. Add 3 to both sides. So x equals 3. So we know that the x-intercept is 3, 0. And then we know how to graph this one, right? It's just, it's vertical, right? So now we can graph everything. Let's see, we know this is going to be, this one's going to be dashed, right? Because it has this will be dashed, a dashed line, and then this will be solid. So let's graph it. So this is 1, 2, 3, 4, 5. Okay, so for this one, we know two things: the y-intercept and the x-intercept. So the y-intercept is 0, -3, and then the x-intercept is right here, 3, 0. And we said it's going to be solid. I mean, dashed, not solid. So this is good. We will label this as y equals x minus 3. Okay, now we got to figure out the shading part. So we can use the point 0, 0, right? So I'll put it right here. So is 0 less than 0 minus 3? Is 0 less than -3? If you're confused, you just here's -3 and here's 0. Is 0 less than -3? That's false. 0 is greater than -3. So wherever this region, it was false. So I'm going to do just a light shade. I'm not going to shade it completely for right now because I have to shade, I have to figure out this part as well, this region. So it's going to be just a light shade. Now let's graph this part. X is less than or equal to 4, so it's right here. 2, 3, 4, and we said this is solid, right? Because it's equal. We can call this x is equal to 4. Now I got to figure out which region to shade. So I can use 0, 0, because it does not pass through that point. So I'm going to use 0, 0. So put it in this original equation. So is 0 less than or equal to 4? So if you ever get confused, so here's 0, and here's 4. 0 is less than equal to 4. So we got it from here. You know what? I'm not going to use 0, 0. I will use 5, 0. Here's 4. Yeah, 5, 0, because yeah, let's use not 0, 0. Let's use 5, 0. So is 5 less than equal to 4? Here's 4. Here's 5. Is 5 less than... No, right? It's false. 5 is greater, so it's false. So we got this point. We said it's false, so we have to shade it on the other side. So, but I'm going to shade it this region because I have to shade that both satisfies both regions. So it's going to be this whole region, not this. I'm not going to include this part because it doesn't even satisfy both parts. So it's just this region. So I'm going to use a different color. So it's just this entire region. So yeah, for the shading, when you're involving two inequalities, it has to the shaded region has to satisfy both areas. Okay, let's do the next one. Let's do absolute values. So let's say you're given x, absolute value of x minus 1 is less than 2. And then we have the absolute value of y minus 1 is less than 4. So remember absolute values, you have an or, right? You have to make it into two problems where we have one is positive, one is 0. So we can rewrite the first one as x minus 1 equals 2, or x minus 1 equals to negative 2. So when you solve for x, you're going to get x plus 1, plus 1. So that's x equals 3, and then you add 1 here, add 1. So that's going to be x equals negative 1. The same part for this one. So remember, we're going to make it to 2. So it's going to be y minus 1 equals 4, or y minus 1 equals to negative 4. Add 1 to both sides. So you get y equals 5, or y equals negative 3. Yes, negative 3. Okay, and we know how to graph these. So this is going to be vertical, and this is going to be horizontal. Let's see. They are both going to be dash because there's no equal sign. So it's going to be dash here and dash there. So let's start graphing. I will start with this part, this one. Okay, so here, let's graph the first one. So we said we can, here's x equals -1 is right here. And we said it's going to be dashed. Call this, whoops, we'll call this x equals -1. So this is going to be x equals 3. Now I got to figure out which part should I shade. So I'm going to use 0, 0. And then I'm going to put it in this original one, not this part. So it's going to be 0 minus 1. Absolute value 0 minus 1 is less than 2. So 0 minus 1 is -1. And then it's the absolute value of that. And we know that when you take the absolute value, this becomes positive. So is 1 less than 2? So is 1 less than 2? Yes, 1 is less than 2, so that's true. So we got this point from here, so I'm going to do a light shade because I got to shade the other part as well, so it's going to be a light shade. Okay, now let's graph this part. So it's going to be horizontal, so here's -3, 1, 2, 3, and it's going to be dashed. Call this y equals -3, and then we will call this, and then y equals 5 is 1, 2, 3, 4, 5 right here, and it's dashed. Call this y equals 5. Now I got to figure out which region can I shade, and I can use the point 0, 0 because it doesn't cross that point, so I'm going to put 0, 0 into this equation. So it's going to be 0 minus 1 is less than 4. So that's going to be -1. Absolute value of -1 is less than 4. And then the absolute value of -1 is just 1. Is 1 less than 4? Here's 1 and here's 4. 1 is less than 4, so that's true. 1 is, yeah, sometimes I have to graph it. So that's true. So we got it from here, so we can shade it, and we can shade our region, right, this whole box, right? I'm not going to shade it here because it doesn't satisfy the other inequality, so I'm going to shade just this region, and I'm going to use a different color. So it's going to look something like this. Okay, let's do another one. Let's do a circle, and So let's do this one. X squared plus y squared is greater than 4. And then absolute value is less than or equal to 4. So for this part, I can rewrite this as x squared plus y squared equals to 4. And we know this is a circle, so it has it doesn't have any number, so the center starts at 0, 0, and then it has a radius of just 2. It's always the square root of this number, so it's just 2. And now remember, absolute value, you're going to have two answers. Remember, so it's going to be x, we can write it as x equals 4 or x equals negative 4. So we know everything, so we can start graphing it. I'm going to graph the circle first. So we said the center, the circle starts at 0, 0, and wait, is this going to be solid or dash? It's going to be dash. So center is 0, 0, and then you have a radius of 2, so at 0, 0, you go right 2, 1, 2, left 2 from 0, 0, so 1, 2, negative 2, and up 2 and down 2, so 0, 0, 1, 2, down 2. And we said it's going to be a dash, so it will look something like this. I'm sorry if mine doesn't look like a circle. It probably looks like an oval. Yep, there's your circle. So this, and we can label this as x squared plus y squared equals 4. Now we got to figure out which region should we shade. So I could use the point 0, 0 because, wait, I cannot use 0, 0, right? Because it passes through, that is our center, so we can't use 0, 0. So what can I use? I will use, I can use 3 commas. I'll use this point. 0, 1, 2. I'll use 3, this point, 3 comma 0. So I'm going to use 3 comma 0 as my testing point. So I'll put it in this equation. So 3 squared is 9 plus 0 squared is 0 is greater than 4. So is 9 greater than 4? True. 9 is greater than 4. So wherever that region is, so I'm going to shade, I'm not going to shade inside the circle, I'm going to shade outside of the circle. So it's this whole thing. And I'm going to do a light shade because I don't know. Because I still have to graph the other one. So our other equation is x equals 4 and x equals negative 4. So here's 3. And this is going to be solid, right? Solid because of this, the equal sign. So this is x equals 4, and then negative 4 is right here. 1, 2, 3, 4. Oh, sorry. This doesn't look nice. Okay, so now I got to figure out which region. So I got to do my testing point. What can I use? I can use, it does not pass through the point 0, 0. So I can use 0, 0 for this part. So the absolute value of 0 is less than or equal to 4. So the absolute value of 0 is just 0. Is 0 less than or equal to 4? Here's 0 and here's 4. Yes. Wait, should I use 0, 0? No, I won't use 0, 0. I will use... Oh, I don't know. I'll use this point, -5, 0. So it's going to be absolute value of -5 less than or equal to 4. So absolute value of -5 is 5. Is 5 less than or equal to 4? I don't think so. So here's 4, here's 5. It's greater, so it's false. So we got this point, we got it from this point, so we have to shade it on the opposite side because it's false. So it's going to be this whole thing. And I'm going to use a different color. So it's good. It'll be this whole thing besides the circle, besides this part. So it's going to look something like this. Yes, the shading is important. So you get the idea, right? Okay. And this will be our last problem. So we have y is greater than 2 to the x, and then we have three inequalities. So y is greater than 2x, and then y is less than 6 minus x squared, and then x plus y is greater than 0. So we can rewrite the first problem as y equals 2 to the x, and then the second problem we could write it as y equals, I'm going to write it as negative x squared plus 6. And then for this one, I'm just going to solve it for y, because if I just leave it like that and I found the x and y intercept, it'd still be 0. So it's going to be y is equal to, so I'm going to subtract negative x from both sides, so I'm going to get negative x. Okay, so we know how to graph this part. I think we graphed it earlier, so it has y-intercept of 0, 1. It's increasing, and this is going to be dashed because there's no equal sign. What about this one? We know, okay, so this is like a parabola, so it has a y-intercept of 0, 6, and then this negative x squared is going to be a reflection on x-axis. And then we know this is just a negative linear graph, so it's we know how to graph this. So we can graph it now. Sorry if my graph looks weird. Call this the x-axis and then call this the y-axis. So let's graph the first part. So we know the y-intercept is 0, 1, and it's increasing, so it's going to look something like this, and it's going to be dashed. Oops. So this, we call this y equals 2x, and then we got to figure out which region should we shade, and we can use the point 0, 0 because it does not go through that point. So let's put it in that. So is y 0 greater than 2 to the 0? Anything to the 0 power is just 1. So is 0 greater than 1? False. So we're going to shade, I'm going to do a light shade to this part. Okay, now let's graph the other part. So I'm going to graph this part. So the second inequality. So it has a y-intercept of 0, 6. Here's 1, 2, 3, 4, 5, 6. And it's going to go downwards because there's a reflection, and we know it's going to be dash as well because it doesn't have an equal sign. So it will look something like this. So we could call this y equals negative x squared plus 6. Now we got to figure out the shaded region, so I could use 0, 0 as well. So I'm going to put it in here, this original equation. So it's 0 less than 6 minus 0 squared. So that's going to be 0 less than, 0 is 0 less than 6. I think so. I'm not sure, but here's 0 and here's 6. Yes, it's true. So it's going to be so I'm going to shade it in this region. I'm going to do a little bit of darker shade because now it satisfies this equation. Now I go graph the other one. So we're going to graph this part. So we know how to graph this. It's just a negative slope. It starts at 0, 0. So we could go down 1, right 1, down 1, right 1, or up 1, right 1, up 1, right 1. And we said this is going to be dashed because there's no equal sign, so it will look something like this. We will call this y equals negative x. Okay, so we can't use the point 0, 0 because it passes through the origin. So what can we use? We can use 4, 0 right here. So 2, 3, 4. 1, 2, 3, 4. So this is 4, 0. Let's see if it's, so we put it into this original equation, so that's our x and this is our y. So 4 plus 0 is greater than 0. Is 4 greater than 0? Yes. Wait. Actually, let's use let's not use 4, let's use 1, 0. So 1 plus 0 greater than 0. So is 1 greater than 0? True. And we got it from here. Okay, if we use 4, 0, it would still be, it wouldn't matter. So remember, it's the region that satisfies both, so it's going to be this part. It's not going to be from here to here, because it has to satisfy both inequalities, so it has to be here. So this is how it's going to look like. Okay, that wraps it up for this section.